Hey guys, what's up? Eddie Alho here with KissAnalog.com. Today, I have a review I'm going to do. Well, it's not really a review, it's more of a box opening. It's just a quick kind of introduction. Yeah, we're going to do a lot of videos on this guy. So, what I want to do is I want to kind of start off by telling you what's special about this. It's a scope. I'm going to show it to you here in a moment. I've got this big SIG. I like it a lot. I like the flat display. It's a large display. It's nice. It's touch screen. I actually like the touch screen on this scope. I've used some that I haven't been a fan of. I used some really expensive scopes that kind of took me a while to get used to them. This one is really easy. The GW Instax, nice big display. I can get rid of menus. Pretty cool. You know, the signal back here is one scope I started with. Now, one thing I like about all three of these scopes, they have what I call deep memory. Siglant's 14 megasamples, and that's between the two channels. So if you use them both channels, you get 7 for each channel. 7 meg. That's a lot. It's still deep. Now this guy's 10 meg per channel. Okay, the mixed sig, I think it's 24 or is it 28, but still a lot. Now that's divided up between the channels too. Still, it's a lot. It's great. Been happy with the deep memory on these scopes. All right. Well, now I got one that I'm going to show you that has 200 megasamples. That's nuts. I mean, the only thing I've had that anywhere close to that are those really expensive scopes that work. Now, what makes those scopes really expensive? Well, one thing is all these scopes are 8-bit scopes. Pretty much, unless you spend thousands, I think you got to spend, I don't know, I'm just going to throw it out there, say $6,000 or more, you're going to get an 8-bit scope. You know, maybe I'm wrong. Maybe it's 4,000. Somebody's going to say you can find. But anyway, I don't know. I think $6,000 to $8,000 you're going to get 12-bit. Okay? So what does that do for you? Well, that's how many steps of resolution you have vertically. Okay? We know about the mega samples, the samples, how many times the waveform sliced up and, you know, then connected. You're connecting all those dots up, right? You want to have lots of samples. We know that. But vertically, when your waveform, when your analog to digital converters looking at that analog signal and telling your digital converter like, oh, okay, here's we just passed this platform, we just passed this one. It can take 8 bits and divide it up to 256 slices. Okay, so let's say you have a 1 volt waveform. It can basically sliced up into 3.96 millivolts, I think it is, per slice. So you get 3.96 millivolt resolution. All right. So that's kind of what that means. With 12-bit, you get 16 times that. You get 16 times better resolution theoretically. Okay. Now, what that also means is your front end, where your probes are plugged into, have to be very low noise. I mean, right? I mean, you know, and that's why I say theoretically. There is some noise that might ruin some of those bits. You know, maybe you lose a bit or two or something. I don't know. But anyway, if you are going to have that high resolution, you have to have a really low noise front end. Okay? So, yeah, this scope has 12 bits instead of 8. It actually can go to 16. So some scopes, and they're 8-bit scopes, I think can go up to 12-bit with high resolution. This one, 12-bit, can go to 16 bits with high resolution mode. The other really cool thing about this scope that I'm going to show you here is it also has 4 channels, but each one is a differential input. These are single-ended inputs. The outside connection, the ground connections, the chassis, right? So single-ended meaning you have one signal, and then the coaxial cable, the ground shield, you know, is your return. That's your second, you know, connection. That's your minus connection. With a differential, like this is a Pintec differential amplifier, has a plus minus cord that plugs into this thing. Okay, these are tied to my mix sig. And I think these are the wires to this guy. So I've got all these boxes up here. I have 3 of them. So I have 3 differentials. So when I'm often when I'm hooking up my mix signal and I'm looking at things, I got 3 differential probes like this. So I got all these boxes scattered around the desk. This one they pull out of. The other thing is, not only do you have a coax coming out of this and your you know, whatever kind of connections you're going to use on this end, you also have a power connection. So this guy has a little jack here. The mix sigs have a USB connection. So I've got these USB cables tying all these boxes together, which means sometimes I can't just line them up next to each other because they plug in the side. And anyway, so sometimes I get, you've seen my videos, maybe if you look over here, there's kind of a mess. A bunch of these boxes all tied up. This box usually sits here. This scope has 4 differential inputs. So each input has a differential input. Pretty darn nice. When you're doing power supply work, they're isolated. They're basically high impedance isolation inputs, right? So that's what's cool about using these differential scope probes that you guys see me using a lot. I don't have to worry about my grounds being connected and shorting something out in my circuit or shorting my scope probes together through the scope, right? So we got PicoScope here. Pico Technology sent this to me. I reached out. They said they had some loaners. They're going to send me a loaner, and I kind of picked one out. They have, I think, 6 different scope series. Okay, so this one's the 4000 series. I picked one out in the 4000 series, which has those, you know, 12-bit high-res mode, and so it's just like deep memory. A lot of their scopes have deep memory, but this one has the differential inputs. That's what makes this one special. So let me pull it out of the box here. And so that's what I'm going to do, is just kind of show you what's going on here. Now, it's a USB scope. Okay, there we go. Comes in a really nice case. So, yeah, it's kind of big. So bring the camera, I guess I go in wide angle mode, huh? But it says differential PC oscilloscope. So, you know, it's what a lot of people call the USB scopes, right? So let's open this guy up, and yeah, it's got this nice hinge. It goes all the way across the bottom. It has these little clam shaped, you know, things, but you know, okay, here, let me just show you the inside of this thing. So there's the scope right there. There's a power connector, a bunch of different adapters here. Now these probes here, I'm waiting for those. They're still being built, so they kind of, you know, whoops, let me show you the other side of this. You pull these little things, guys, down, and then disconnects this guy and shows, I'm going to show you these probes. We'll pull them out of the bag. Okay, I haven't had them out of the bag yet even. So, been excited to show you this. I've had it for a little bit, and we'll pull it out of here. Okay, so knocking over everything on my bench. So there we go. There's our scope. So, you know, they're saving a lot of money. They don't have a big power supply. They don't have all the electronics that runs the display. So it's just a front end. Basically, it's the front end of the scope, and then it's going to talk out a USB, and it's going to talk to your computer. Okay. The cool thing about that is this little guy is smaller than all those. You know, if you had 4 differential boxes, you saw the one, the Pintec, right? I mean, you can see, you know, it only takes a couple of these to be almost as big as this guy, right? So, so it's actually fairly small, sitting on your bench. You got these D9 connectors. They're sub D kind of 9-pin connectors, and it's channel A through D, A, B, C, D. So you got 4 channels, and yeah, with something like this, they have PicoScope 6. I think they call it PicoScope 6 software right now, and it runs all their different scope series. So that's pretty cool. So they got one software platform for all these different scopes. They're not spending money on the display and all that. So you're really putting your money into just buying the front end, that low noise differential input that has 12 bits and still go to 16 bits, and it has 200 megasample memory depth. So Way cool. Okay, let me show you something. The scope has what they call 3 different modes of operation. It has the persistence mode, that's color, looks like it's going to be really cool. Then it also has the regular scope mode, the analog or digital, that or both, so it's like an MSO, okay, multi-signal type oscilloscope, and you can break that up into 3 different screens. You can have 3 screens on your computer screen at any one time, so you can look at 3 different parts of your waveform, or break it up how you like. And then it also has a spectrum mode, and again, you can break that up. You can look at both the regular scope mode and the spectrum mode on the same screen. So, super cool. It looks like the software is very powerful. I've noticed that with some of these softwares that run the scopes. Now in the lab, when you have these really expensive scopes, I'm talking scopes that cost $20,000 and that, you'll get this kind of stuff, 12-bit technology and really deep memory. And you also get a wide band width, which this guy, that's the limit on this guy. This guy's limited at 20 megahertz, okay? So you get those, say, 200 or 300 megahertz scopes with all these features, but you're spending 20 grand. Well, with this guy, this high resolution scope, it's awesome for audio work, for, say, switching power supplies. So switch mode power supplies, I can, if I'm trying to get that ripple down really low, say on a 24 volt or 48 volt signal, I've got the resolution where I can zoom in on that. I've got the memory depth where I can look at different parts of the signal, and I'm really excited to use this and see exactly what it can do for me. So yeah, we're going to see this in some videos coming up here, and it's going to be fun. So I'm going to bring the camera over here, show you all the stuff inside this box, what came with it, and then I'm going to then we're going to hook it up to the computer and check out the software. Alright, so here we go. Now, that's both channels. What I want to just show you is the scope. Up here on the top, the menus come across. You can see the volts per division. That's where we are right now. I can pull down the menu, and it gives me all these options. Whoops, I just popped, I heard a clip pop off. I didn't get that on very good, I guess. There we go. Okay, so you come up here and you can get any one of these time waveforms you want. Click on it that way, or you can use the arrows this way. So that's pretty nice, right? Then over here's the samples, how many samples you're gathering. We're 2, 3, 4 meg. I can click in the window and type in what I want, or I can just hit this. So that gives you some pretty deep memory. Then over here you have your 12 bits. I can go to 14 bits, but I'll just stay at 12 bits for now. And then over here is a bunch of windows it's capturing. I'll have to explain this later, but basically it's capturing every time it scans a waveform, it collects it and then it just stores it, okay? And then here's a map for those windows. Here they are right here. See, there's window 32. And if I go back, 31. So it's kind of like segmented memory. And so, okay, what else? Here's your zoom. You can do it that way, just using arrows. And once you zoom, you can see down here in the bottom of the screen, and it shows the box around what you're actually seeing in your screen. You can do this guy right here and just put a box across what you want to see. And then look at that, zoom right in on that. Okay, now one thing I want to show you, let's zoom all the way out. And here's this little hand right here. When you are actually zoomed in, let's do that again. And then if you select this hand, you can just move your picture around and say, oh, I wanted to see right over here. So I think that's pretty cool how you can just move around your window. So up here you can see, all the things, the selections you have. The next column, or the next row here, is your channels. This is channel A. See, when I click on that, and then I can go into this high res thing. I can even go higher res than that. Look at that, 18 bits. So it's pretty crazy what you can do with this thing. You got some filtering. This stuff gets, you know, pretty detailed. We'll have to do a video just on that alone. Then your auto, so you can go, right now we're auto scaling. We can choose a scale here, DC, AC, and then you got your channel B, all the same stuff, and then channel C, channel D over here. So right now we don't have a probe on these guys, but yeah, so you have all your same options. The thing is see, right now it says auto. This is off because there's no probe. If I turn it on, just so I can pull down the menu, then I can look at the menu. But it's off right now, so that's how you turn them on and off. Down here at the bottom of the screen, okay, down here at the bottom of the screen, you see it says stop, so I can hit the green arrow, get it running again. I can hit the red box. Now the thing is, I'm not sure about, I'll have to, if I just do this, I can run and stop it this way too. So I'm not really sure the difference between hitting this off, says stop capturing. Maybe this is more of a pause and this is the off. Anyway, yeah, I have to learn things about this, guys. Of course, it just pulled out of the box. So there's trigger auto. Okay, now it's locked in. And then you can pull this up. Look at all the different things you can do with triggers. So you can go, look at these. And look, for instance, when you pull up these things, it shows you these windows. And when you go here, when you close this, here we got to zoom out so we can see what's going on. You can see this little trigger window, and see that little thing right there. So that little guy right there is whatever we're messing with. It says pulse, and so it'll show you on the screen what it looks like. It's got some hystereses. I guess we're at 7%. If I stretch out more, we can get more. But yeah, that's yeah, pretty sophisticated triggering going on, and we'll have to play with that some more, obviously. But okay, that's falling edge, rising edge. And here's a threshold. See, we're right in the middle of the screen right now. I can type in a number just like I can in any of those windows, or if I just hold this down, click it a bunch of times, you see the little yellow box, the diamond here has gone up. So come back down here, put it back down to 0, or just type in 0. Okay. And then 50%, that's right in the middle of the screen. If I want to bring it over this way or that way, I can type in what I want, or I can do it this way. So you can see that our diamond's over here on the left side of the screen now, because I'm at 0. So let's go back to 20%. You can see it moving across. There's 50%. And 100% is the far right of the screen. Okay, and then what is this guy? Okay, if I hover over it, it comes up and it says time delay. Okay, and it shows a little arrow, so I can see that, oh, okay, there's going to be a little arrow there that I can drag and time delay it. And look, you can actually just grab that trigger, it looks like, and just move it where you want it. So if you don't want to play with the menus, just grab it and move it. And then look at the measurements. If you want to do a measurement, channel A, look at the pull down here. There's just all kinds of measurements you can choose. Just say ACRMS. And then look, you can do the whole trace or between rulers. Now, by the way, over here on the left of the screen, you see these rulers. It's set inactive, but now I pull it out here, so I can put this at the top of that waveform there. And then I can grab the other one, move it over here. And then up here on top, it tells me where cursor 1 is, cursor 2 is, and the delta, the difference between them. Now look over here on the far right. This is interesting. This is a phase thing. So let's say we go, okay, we start put one right there. That's 360 degrees. Let's grab this one. That's the 0 degree phase. So let's put 0 over on this one. Okay, so then when we put it that way, it shows that's supposed to be at 0 degrees. That's supposed to be at 360. And over here it says 1 kilohertz. Now down here at the bottom, you see the measurements. What we have to do is we have to come up here at the top of the screen, and we go to measurements, and we can look, that font size is 7. We can definitely make that bigger. There we go. Now it's easy to read. I'll just show you the toolbars here. Here's toolbar. Man, a bunch of math things, reference waveforms. Here's the measurement waveforms. See, there's a deep measurement too. That's going to take a video just to show you that. Here's your different views. Okay. So some of these things are just right out here on the toolbar, and some of them are up there where you have to grab them. Down here at the bottom, you can see the rulers, the arrows, and I can assign the degrees, percentage, or just change that how I want it. And there's actually a notes section too. So see, there's notes that come up here. That's really nice. All kinds of different measurements. Okay, so let's see. Now, here's something I haven't shown you yet. Over here on the far left, it's highlighted. That's the scope mode. Right here's persistence. So you see how the colors are changing? It's showing you what's happening more often than what's not. That's our persistence scale. We can get some different waveforms, but you can see this amplitude we're putting out is 124 millivolts. It's not super clean, right? Well, if we go over this next little tab right here, it says spectrum mode. See, if I hover over it, it tells me what it is. So if I push that, wow, look at that. Now I've got spectrum. And then up here, it says 13 megahertz. So, okay, maybe I want to go to, let's try 200 kilohertz. Well, look over here on the far left. Let's drop that down to 10K. So each grid is, look, 1K, that's our signal that we're putting out right there. And it's, yeah, I mean, it's looking like it's below 13 dB right there. There's measurements you can do on this as well. That's the amplitude at peak. Let's do that one. Okay, right down here, look at that, 16.19 dB. And it tells you how many signals it's capturing. So it's scanning across the screen, capturing, it's up to 10 right now. So there's our spectrum. This is going to be fun to play with, this spectrum. See, the ground floor down here is down and went 91 dB. It's pretty darn low, guys. And right here, this is our, how we can set up the bin. Here's the bins. So let's say we want to go a little higher count. That's going to collect a lot more data. It's going to slow things down. We got our different filters. Look at all the different filters we have. Lots of different filters. Our display mode, magnitude, there's logarithmic, dB microvolts. We got volts, dBm, and arbitrary dB. So you can assign, I think, what ohms you want to that. And X scales linear. Let's make that logarithmic. Yeah. And then look, here's your decades. We go 5 decades. We can go less, 3 decades. So let's go higher in frequency now that we got some log stuff going on. Let's go 1 megahertz. So it looks pretty darn powerful. The software is pretty incredible. Okay, so what I want to show you here is, this is the Pico website. The scopes right here, the different series, the 2000 series right here, it is what they call the ultra compact 8-bit. Now, even though these scopes may say 8-bit, you have to look down into, the channels, because some of them have, I think many of them have the high resolution where they can go to 12 bits or higher bit. Now the PicoScope 3000 series, starts at 579. See, it has 2 and 4 channel. So this is your general purpose. This is more of what a lot of us are used to. Physically, it looks like it's the same size as the 4000 series, which I have here. Now, the 4000 series, you see it starts at 849, okay? And then the 5000 series, it is a high resolution. So it is kind of the higher end of the scopes of, like say, the general purpose is a 3000. The 5000's the high bit rate, 16 bits, you see there, and it has a higher sample rate and higher bandwidth and all that. So that's an interesting scope series right there for kind of a higher end. Okay, then the 6000 is a really high performance, 5 gigasamples per second, 300 megahertz to 1 gigahertz bandwidth, so real high bandwidth scopes. Yeah, so that one is the high performance series. So the PicoScope 9000 series is another specialized series, kind of like the 4000, the one that I have, but it is a very high end, very expensive, very specialized, very, you know, high speed type of scope, okay? And you can see the boxes of the 6000, 9000, they look physically different than the 3000, 4, and 5000. They all seem like they have a similar size box. The 2000's that really compact one. I mean, that thing will fit into a pocket. It is small. Okay, now this table here, I just wanted to show you this because if you know what kind of channels and all the different things you're looking for, you can go on here and kind of go through them. But you can see right here, the minimum price is $139. Max price is almost $30,000, guys. So these scopes go from, you know, pretty affordable, $139 US. Now this one's 10 megahertz, lower bandwidth, 8K, so on. It's that ultra compact 2000 series, so very small scope. If you're traveling and you just need a scope that you want to take with you, you know, these things might be the thing to do. They're very, just because they're so small and compact. Okay, now you see the check marks here, the signal generator or the arbitrary waveform generator, these check marks here, and whether they're USB powered. So yeah, you just go down here and look at these prices. I've kind of organized by price, but you see how they just go up here. Let's look over here. The first 4-channel scope is around $449, okay, 25 megahertz. And then when you start to step up, like say the 12-bit, that's that 4000 series, you're up to about $849. That's the series that I have. And so I just wanted to show you this. So yeah, you can see the PicoScopes, they just go, I mean, here we are, almost $20,000. Now look what you get, 4 channels, 16 gigahertz bandwidth, 250K samples of memory. So that's not really deep memory, but look at the sample rate and the bandwidth and the resolution. It's just crazy. So now let's step down here. Look at this one, 4 gigasamples of memory. So if you want deep memory, there you go. 5 gigasamples per second, 1 gigahertz bandwidth. So a very serious oscilloscope, 12-bit resolution, and it has a generator built in for $15,000 almost. So yeah, these guys know what they're doing. I mean, they have everything from the very high sophisticated scopes down to the more affordable scopes. So I think that what that makes me feel like is I have confidence in these lower cost scopes that they really know what kind of technology to put into them, and they're, even though they're inexpensive, they're not going to be cheap, I don't think. So the scope I have is in the 4000 series range, and it is right here, the 444. So see, it's $1285. I think my kit costs a little bit more because I have some probes and I have the case, which I think is $100 for the case. So anyway, So look at that, 256 million samples. That's pretty high deep memory. 14-bit resolution, vertical resolution, 400 megasamples per second sample rate. I mean, you know, so this is going to be a very interesting scope. I just wanted to show you the prices so you can kind of see they're all over the park. Depending on what you want, they have just about everything. Hey guys, so what do you think? You like it? I mean, there's a bunch of different models. I just like this differential version because I used a lot of differential probes. I just thought it'd be a really cool thing to use. I mean, God, there's so many models to choose from. Yeah, I just took this one. It looks high resolution. It's going to be fun to use. I got some buck converter videos I've been doing. Can't wait to try it out, compare it to these other scopes. All right. Hey, any of you guys using USB scopes? Let me know what you guys think of them. Which ones you're using and how they worked out for you. I've never really thought too much about them and never really paid a lot of attention until someone on the channel, you know, pointed. A couple people actually said, hey, why don't you try a PicoScope? So I'm glad I did. They were super nice. Thank Pico for this scope. Man, it's amazing. That pretty cool. Alright guys, thumbs up to the video, helps the YouTube channel, you know, the YouTube analytics, all that kind of stuff. Free way to help the channel. Commenting, all that stuff. That's great, guys. Really appreciate it. And also I want to say thanks to my Patreons. Appreciate you guys. And you become a Patreon for a little $1 a month. Another way to help the channel for free is to use the links down below. I got links for this stuff. And yeah, so appreciate all your help, guys. And I'm really excited to use this in future videos. You know what I was thinking about as I was playing around with this and using my laptop over here is that on the job, when I'm using those expensive scopes, the kind of ironic thing is I'm actually, a lot of times we have a scope hooked up to the computer and we're downloading all the images we're doing versus, you know, saving them on an SD card, taking them in and putting them on a computer later. We're just doing it right real time. So using a USB scope even makes more sense when you think about it. When, you know, especially when you're doing a lot of work that you want to save the images, instead of having to do that transfer, you just already have them on your computer. So yeah, and the big screen, you know, one thing I didn't really get into is that you can also save up to at least 3 screens. So you can have a frequency domain, you know, the spectrum analyzer window showing you the FFT essentially, and having your time domain, having your regular scope screen, and then also zoomed in maybe on 2 different, you know, peaks or something. But yeah, you can have 3 windows on your screen at least at any one time. So that's really cool. And because you're using your computer, even my small laptop, 13-inch screen, still way bigger than I think any scope that I've used. Even the real expensive ones aren't quite that big. I think they're 10-inch. So pretty amazing. Yeah, I think I'm becoming a fan of this kind of scope. We'll see. Okay, we're going to use it some more. And you know, the probes, everything that came with this Pico, everything seems, the case, everything seems that there's a lot of attention to detail, and everything looks like it's of the top quality as far as I can tell so far. So thanks again, Pico. Thanks for all you guys watching the videos. We'll see you next time.